there's a lot of intellectual laziness in the market. It feels like to me the Uberification for mobile type of situation that is happening in AI right now, where Uber said, okay, on-demand drivers. Okay, but Uber had a lot of benefits. They didn't have to own any inventory. It was a real-time marketplace that was really enabled by mobile devices and so forth. And back in the early 2010s, there were hundreds of these Uber for X companies that popped up, and most of them failed. So that's what happens if you just lazily just apply a concept and try to copy and paste into things that don't make any sense. And I think most companies that are trying this FDE motion will likely fail because FDE is not how things work in other domains. Welcome to Agentic Data episode 10. Agentic Data is a podcast about data and AI. I'm Joseph Moon, CEO of Oxygen Intelligence, your host. Today, let's talk about a few news topics that came about in the past week or so. Firstly, let's talk about Gamma, the vibe-coded slides software. So about 4 days ago, Grant Lee, the CEO of Gamma, announced their Series B at a $2.1 billion valuation led by Sarah Wang at Andreessen Horowitz. So one of the main things that Gamma does is it auto-generates presentations from just natural language prompts. I believe that Gamma also does a few other things like generate websites and other creative artifacts that a business owner may need to generate during their course of the day. And what is incredible about Gamma is that they have a user base of 70 million users and only have 50 employees with $100 million in ARR. So $2 million per head, extremely efficient growth, incredible scale of user acquisition, and also pretty impressive that Gamma was able to cut through the noise despite early competition from others. I think namely, there was a company called Tome in the space that garnered a lot more users, raised a lot more funding, had a lot more hype before Gamma ever did. And it seemed like Tome was the natural winner in the space, the king-made company, if you will. But I think Tome had a change of plans, had a strategic shift in its business. The founders of Tome pivoted away from the slide generation software and moved into building agentic CRM software. So while we don't know what really happened underneath the hood, what happened with their board members and other investors, etc., what we know is that Gamma seems to have caught on a lot more traction and has survived enough to really reap the benefits of what it seeded a few years ago. The thing that I really like about Gamma is its interface and how thoughtful the interface is. So Gamma's homepage is really unlike any other tool that I've seen in the generative slide space or generative artifact space, in that it really handholds the user in creating the artifacts that you want. And it really handholds the user in starting from a starting point that makes sense to the user. I could paste in text, I could generate from a one-line prompt in a few seconds, or I could import file or URL, or I could remix a template. And so once I click one of the options, I go into this generate page. What would you like to create today? Presentation, website, web page, document, social, etc. How many cards do I want? There's some example prompts. I think unlike ChatGPT and other tools that I've seen, this tool is not completely chat-based. There are guardrails and buttons that users could click to generate their artifacts. And I think this is likely intentional in its design. It's probably from a lot of analytics data and user surveys and anecdotes about how one wants to use the software. Making it easy for novices to use the software is the key to Gamma's growth. I think this reminds me of the early days of Canva, the easy-to-use design software that is growing very rapidly, perhaps growing more rapidly than, say, Figma. And if history rhymes with the past, I think a tool like Gamma would become a lot larger than a tool that is specifically for designers in making more design-focused collateral or design-focused end products. And so there is great value in building a viral and bottoms-up software that aims to capture all knowledge workers, all 1 billion knowledge workers, rather than say, the 1 million or so designers and design adjacent folks that exist in the market. And it's very clear that Grant and others spent a lot of time thinking about how to make things as simple as possible for the end users, and their strategy is quite clear. So I think this is not an accident that Gamma was able to get this far, and this is yet again another lesson in the story of don't give up too easily, just keep on fighting, keep on pushing. You could play the game of trying to kick out a tool that already exists in the brain space of a user, or you could play the game of taking the time that users are spending in doing other activities and just inserting yourself there. That could be a pretty valid strategy. So it looks like Gamma is not fighting against players like PowerPoint and Google Slides and so forth. It's likely fighting against folks that would otherwise not generate slides so quickly. Okay, moving on. So let's move on to the second piece of news that I wanted to talk about. And this news is about Inception Labs. Inception raises $50 million to build diffusion models for code and text. This round was led by Menlo Ventures with participation from Mayfield Innovation Endeavors, Microsoft's M12 Fund, Snowflake Ventures, Databricks Investment, and NVIDIA's venture arm, N-Ventures. Andrew Ng and Andre Karpathy provided additional angel funding. The leader of the project is Stanford professor Stefano Erman, whose research focuses on diffusion models, which generate outputs through iterative refinement rather than word by word. These models power image-based AI systems like Stable Diffusion, Midjourney, and Sora. Having worked on those systems since before the AI boom made them exciting. Erman is using Inception to apply the same models to a broader range of tasks. Now, this is very interesting because this company is applying a differentiated architecture and changing the modality completely. So instead of having diffusion generate images and videos and so forth, it's going to apply diffusion to text. And of course, Elon Musk had something to say about this. And this is a very Elon thing to say. Elon believes a majority of AI workloads will be diffusion models. Elon says on X, diffusion will obviously work on any bit stream. With text, since humans read from first word to last, there is just a question of whether the delay to first sentence for diffusion is worth it. That said, the vast majority of AI workload will be video understanding and generation, so good chance diffusion is the biggest winner overall. Also means that the ratio of compute to memory bandwidth will increase. I think this is a very Elon-like thing to say. He likes to simplify architecture whenever possible. An example of this is that in a Tesla runs on just video bitstream to run its FSD. So instead of, say, Waymo, which uses LiDAR and other sensors to get the input information to power their Waymo full self-driving, for Teslas, that is not the case. And I'm sure one reason for this might have been cost in the early days, but since the cost of LiDAR and other hardware for self-driving have dropped dramatically, this is likely no longer the case. But I think in typical Elon fashion, if one could reduce a component from hardware or from an engineering system, then it's much better to do so. And also using commoditized hardware and software, the iteration of these technologies is much faster. Say, camera technology evolved a lot faster than other technologies just because cameras are used everywhere. And because of that, there's a massive pricing pressure for all vendors involved, and there's a lot more innovation there. So really staking your ground into something that is more universal, has a lot more legs in technology rather than simply relying on something more specialized. And of course, this will make sense for AI systems as well. Right now, there are at least two main architectures for AI. One is the transformer architecture for doing language understanding and language generation. And then there are diffusion models for images and videos and so forth. And they use totally different architectures to generate things. And generally speaking, for videos and images, you're looking at a grid of pixels, right? And you're looking at a grid of pixels, and more specifically, it's a grid, but at the same time, it's a multidimensional matrix, so to speak. So it's a tensor, and you're looking at the tensor and doing computations on top of that. And the understanding is that the neighbors, like if you have a specific pixel, the neighboring pixels give you a lot of information about this specific pixel, and then that kind of generalizes towards the whole image or the whole video And that kind of data shape is standard for videos and images, not standard for language. For language, you have sentences, and so you break up these sentences into words or tokens, and then you get the language model to train things in an autoregressive way to try to predict the next word. And so it's a slightly more limited scope that uses embeddings to represent words in the semantic space. Whereas for images and videos, you have tensors, and you're trying to look at these tensors and see the pixel values and just see this in a more tensor or matrix specific formats. So it's a very different data problem. But if you reason things out, the human eye also is looking at like a piece of paper or monitor or something like that, and it is actually absorbing that information using our eyes and using human vision to interpret that. And the human brain, it may have a separate place where a large language model like autoregression is done, but what likely happens is we have a unified architecture that takes in the visual information and tries to process that in a way that is standard across one looking at an image or trying to understand a piece of text. It's still all done through the eyes. So from that perspective, Elon thinks that everything should be unified under that kind of paradigm just because you could learn from how biological systems work. So one could always analogize how a biological system has evolved through evolution and then try to apply that to machines. So the end product is not going to be the same. Like an airplane doesn't fly in the same way that a bird flies. But that analogy and that simplification makes a lot of sense because through evolution, through millions of years, biological systems have evolved in an optimal way over a long period of time. And in some sense, all deep learning is doing is taking the training data from physical systems and trying to learn patterns from it. And so in some sense, it is actually going through an evolutionary process itself. So why not just learn through biological evolution? I think so. That's sort of like the longer thread of how Elon thinks about it. But it's a typical Elon thing to think in this fashion. So this is super interesting. And I think one thing I want to add onto here is I think because of AI, standardized hardware like GPUs are going to be a mainstay in the compute foundation. So previously you had a computer architecture that relied very heavily on the CPU, on hard drives, and some amount of visual computation. But we are in the decade of GPUs. In the next few decades, the GPU as a new paradigm of computing, namely through deep learning, is going to be the standard for computing. And if that's the case, a lot of consolidation around the GPU is likely going to happen. And GPUs are very effective for not only visual processing, but for basically anything that has to do with tensor math. So anything that has to do with tensor math and tensor calculations. So doing addition, multiplication, matrix operations on the tensor, it's really for that. So if the GPU becomes such a mainstay in the computing foundations of the modern technological society, then everything probably is going to be rebuilt on top of that. Things that were generally more compute and CPU intensive, like query engines and data, for example, could be seen to be rebuilt by being GPU accelerated. And I think NVIDIA is working on GPU accelerated query engines for structured data. So that is happening. Having your, say, query engines and your language models and diffusion models in the same place is going to likely be a better architecture for the future. An architecture that combines language understanding and image and video understanding on the same neural net in the same line of reasoning is likely going to be the better architecture. So there is this consolidation force around the GPU that is happening, and things will likely be refactored. And I think this implicitly is another argument for the consolidation of everything into more diffusion-based models. And of course, for an application provider, it doesn't really matter whether your model is diffusion-based or not. As long as you could play with the outputs and modify the inputs, you're fine. But I think perhaps this architecture battle of what architecture is better is going to rhyme with the architecture battle for databases. And so I think in the beginning of databases, there's a lot of debate on whether the relational model was going to stick, whether the document-based model like MongoDB was going to be better. Some debate about whether you should have this all-in-one database system, HTAP systems that could run transactional and analytical workloads, all these things, whether Hadoop, this MapReduce framework, was going to be the thing that takes off, all these debates, and things just equilibrated around a few different objects. Postgres was truly a winner, a standardized relational model for basically all types of computing, except for analytical computing. In that battle, vendors like Snowflake and Databricks, those folks are really winning here. But I think in this inning of Postgres is also now being extended to add analytical support through iceberg tables and so forth. So that is happening. Perhaps diffusion-based models is going to be sort of the Postgres in the AI world, or it could be seen as the next HTAP. Maybe you should have different architectures for the transactional and analytical workload analogs in the AI space. That being maybe the diffusion-specific workloads, images and videos, and then like transformer-specific workloads, which are language workloads. So I think both things can be true. It is not necessarily the best technology that really wins out at the end of the day, even if it's better. It's usually the technology that gets to the network effects faster to establish a standard that becomes the main thing that has staying power. So let's see what really happens. And let's see if the elegance of having a singular architecture for video, images, and language, if that's going to be the leading factor in pushing that architecture forward, or the separation of concerns and use case specific architectures are going to really push things forward. But there's going to be a really interesting interplay here between physical robotics, like physical robotic systems, as well as software systems in pushing things forward. And if, say, robots are going to be the new modality, a new type of phone that every consumer has, then it might be the case that for those systems, the visual system is going to be the most important part of their brain, so to speak. And from that perspective, then it may be more plausible that a diffusion-based system might win out at the end of the day for robots, because more robots may be running software systems and operating systems and AI models than any other type of computer. And that may well be the case, just humanoid robots. So let's see what happens. Okay, let's move on to our deep dives. So today, I wanted to talk about forward deployed engineering. I think there is a lot of confusion in the market here, and people like to talk about Palantir, especially its stock price and things like that. And I have talked to my own investors about Palantir and so forth, but it's entirely clear to me that while people like to talk about Palantir, nobody really knows what they're talking about, and nobody really knows what they're talking about in terms of forward deployed engineering. Of course, I did not work at Palantir, but I have competed directly with Palantir at my previous company, Quanco. And so I have some knowledge about how they work, just because we studied them so we could compete against them. And I think one thing that folks forget is that Palantir is not a company that just one day decided, oh, we're just going to do FDE because they feel like it and they want to do it. This whole FDE motion is incredibly painful just because there's just so much traveling involved. You have to price your services very high so that you could justify having a labor force that gets deployed on site. It's really hard to recruit because you're effectively recruiting folks that could be like McKinsey consultants as well as hardcore software engineers or AI engineers. It's very, very hard to find that kind of person in one person. And so recruiting becomes very, very hard. And so there are huge limitations of this model. The reason why I think it makes sense for Palantir or for data companies is because if you're providing data analytics solutions, it makes a lot of sense to deploy folks that are going to build end-to-end solutions around a data platform in a bespoke way, because that's precisely what data folks in an organization already does. So data scientists, they already serve as these FDEs embedded within your organization that gets inquiries from other teams, transforms those inquiries into data products that other teams could use. And they oftentimes serve as the point of contact to drive internal initiatives. And these internal initiatives look like consulting projects. So I've been a data scientist for the past 15 years now, doing a lot of AI and ML and traditional analytics and so forth at places like Wayfair, and work with companies like eBay, Rakuten, etc. Large companies, large consumer companies and technology companies. And the good data folks already operate like FDEs, and they really work with stakeholders to drive initial internal initiatives like dynamic pricing at e-commerce companies, demand forecasting, and optimization of ad targeting through uplift modeling, causal inference, all sorts of things. And those initiatives are done to generally get to better business outcomes, generally in increasing revenue and decreasing costs. It's as simple as that. Increase revenue through better ad targeting, decrease cost of goods through better demand forecasting, better inventory management, all these things. And so, of course, it makes perfect sense if you're going to sell a data and AI platform that the folks that are going to help you solve problems are precisely the data people that would have solved your problems in the first place without Palantir, without a vendor. So this makes a lot of sense, but I think there's a lot of intellectual laziness in the market. It feels like to me, the Uberification for mobile type of situation that is happening in AI right now, where Uber said, okay, on-demand drivers, okay, but Uber had a lot of benefits, like they didn't have to own any inventory. It was a real-time marketplace that was really enabled by mobile devices and so forth. And back in the early 2010s, there were hundreds of these Uber for X companies that popped up, and most of them failed. So that's what happens if you just lazily just apply a concept and try to copy and paste into things that don't make any sense. And I think most companies that are trying this FDE motion will likely fail because FDE is not how things work in other domains. If you are in the software domain and you are selling a product that aims to automate code writing, then a lot of the cases, you probably want to sell your product in a PLG fashion that is optimized for distribution. So companies like Cognition Labs and Cursor, these companies are canonical companies that are doing this developer-led uptake of these services and products in a good way. And that's probably the best way forward. For data, I think we have learned at my previous companies that doing a PLG type of adoption-based motion is incredibly hard and almost impossible. It is possible in narrower domains like analytics engineering, so data engineering or building pipelines, that has a dev tools like aspect to it, but there are no companies that really succeeded as, say, like a BI tool or a data insights tool or even a data warehouse tool that really had a bottoms up type of motion in commercialization. So there may be an aspect of, okay, people love, say, DuckDB or ClickHouse as an open source tool, but that's now how those products are commercialized. It's still a relatively sales heavy process of getting those through the finish line and getting them deployed in organizations. And so code, likely the PLG thing works. Data, it doesn't work. Our thesis at Oxygen Intelligence is that the FDE motion will work very, very well for data, because with AI, you could deploy end-to-end solutions, and folks don't want this old way of just buying a stack and trying to figure things out by themselves. When the underlying platform becomes very difficult to use, but is very powerful to use, then you will likely need help in getting that set up and getting help in using it, especially in the early days of technology. But as the platform becomes easier and easier to use, the standards become more normalized, and there's an equilibrium point in which folks converge onto certain patterns and folks are more knowledgeable about how to use these systems, then I think a more self-service like situation could arise. But even companies like customer support companies like Sierra or Decagon, the fact of the matter is, I think software engineers are very, very not used to thinking about stochastic systems and AI systems because there's an inherent amount of randomness to the system that is not very commonly understood by general and traditional software folks, because software is deterministic. And if you tell a computer what to do, it's just going to do exactly that. And all bug handling and everything is precisely due to the fact that you could assume that the computer is going to do what you told it to do, and then you could catch bugs because the computer deviated away from the exact pattern that you told it. But if you're working with an inherently stochastic system, then the debugging behavior is going to be very different. And in our experience in working with customers right now, I think it's very hard for software engineers to adopt that kind of mindset. So bridging the gap by having more services bundled in with your platform makes a lot of sense right now. But I think because of engineers wanting to own their stack and to be the masters of their own domain. I think that manifestation of the FDE for software and software-like tooling for things that are not, say, more consulting oriented to begin with, like finance or data, those conversations and those situations will evolve differently from the data platforms that have FDEs bundled in. So very naively following the path of Palantir Foundry. Palantir has a few different platforms, but the most famous one that folks think about is Foundry. Copying and pasting the methodology that a data analytics company like Palantir used and applying that naively, it's just not going to end well for most folks. And there you have it. These are some thoughts of the week, and we will continue this discussion in our next episode.